Well, hello. My name's Chris. I am a human systems integration scientist with the Navy. And today I'm going to explain a little bit about a fictional artificial intelligence pattern slash threat recognition augmentation system. And I will start off with the problem that this system is addressing. The problem is identifying a needle in a haystack, essentially. For the military, the needle is the enemy, who is hiding under cover, in front, behind, underneath, or above the soldier. And there are certain positions, operators, warfighter positions within the military that require warfighters to have very attuned attention to detail when it comes to detecting patterns. For example, human in camouflage. So our system that we'll be talking about today is a helmet-mounted heads-up display system that is being developed as both a threat recognition system when it's deployed in the field, and also as a screening system to help identify the soldiers with especially keen abilities to correctly identify targets using the system. So for the screening component of the system, to find soldiers with unique discernment abilities, several photographic images will be presented. So some will contain a hidden camouflage object, some won't. The essential task associated with the problem is to make a decision as to whether or not a scene contains a threat. So the user will activate the heads-up display system, which is equipped with the artificial intelligence pattern recognition system, and there will be several trials for screening. To successfully pass, the user must show a proficiency of 95% correct detection and less than 5% of false alarms, or claiming to see a target when one is not there. Now, no AI system is perfect, so a 5% false positive recognition will be introduced into the testing screening version of the software, not the deployment system, of course, which will further test the judgment and discernment of the user. So to address the task analysis, I'll say I'm just going to go through the different tasks that will be involved in the screening procedure. So the user will don the headgear and put on the heads-up display, the helmet. Then the user will be presented with a photographic scene, something like this. So the user will initiate the activation, and if a pattern or a threat is detected by the software, it is indicated on the heads-up display with accuracy probability, a value here, and also an indication of where the threat or the system is detecting a threat. And so then the user will have to decide if this pattern really represents a threat, and the user will verbalize whether or not any threats exist in the photographic scene. So an additional step in the field, of course, would be required for the deployment variant of the system. An insight from this task analysis is that the default mode for the heads-up display is that the on mode should not require initialization. The soldier can turn off the AI augmentation, but that step would be removed after looking at the task analysis. So user experience design, the AI-specific considerations of inputs and outputs. So during system research and development, user participants will provide inputs for the preferred method of indicating a potential target detected. So should there be a circle that surrounds the image like I have here? Or should we have an outline of the actual shape of the target? Or should we fill in that image with a certain amount of saturation? And so this is part of the iterative prototyping and testing phase. Other inputs to the AI system will include millions of image files and potential variations of images to improve the detection accuracy of the system. And these inputs will continue to grow as future correct detections are added to a library from use by soldiers, basically a feedback loop. The main output will be the probabilistic versus deterministic indication of the detection of a target. So the transparency of the system is evident through the use of the heads-up display, and the degree of uncertainty is communicated by the saturation level, the type of outline, or the fill of the target, and the percentage of the value that is displayed. So this is much more a probabilistic system than a deterministic system that would say either yes or no, target or no target. So feedback loops, the feedback will be implicit. That is, the system will communicate back to the central server successful detections versus misses or false alarms. And the feedback will not be explicit. It will not require the conscious intent on the part of the user. Privacy issues. Although no privacy laws are foreseeable, no personally identifiable information, PII, will be collected, and users will be informed of the anonymous nature of the screening. Ethical issues, fairness, accountability, and transparency. The most important ethical issue will be to inform those who may not pass the screening test that this is not a negative reflection on them. Rather, it will be communicated that only a very small percentage will pass, and their participation is actually helping to improve the system. Again, the anonymous nature of the results is explained. Accountability. Ultimately, the U.S. military is accountable for all aspects of the screening and fielded system. And controlling for bias, testing will be completely transparent. It is only the participants' combination of brain and vision that are being evaluated. Gender, demographics, and other characteristics beyond those already collected at military recruitment will not be collected or considered. And I think that's everything. Mary, did I get everything?